Welcome to Lesson 12 of the AP Computer Science Saga. Make sure you have your notebook and writing utensils handy. You know sometimes when you're writing code and you keep writing the same 3 lines over and over again, and you wish there's just a simpler way? Well, it's your lucky day because I'm about to tell you all about loops. There are 3 kinds of loops: while, for, and do while. Each has their own perks and setbacks. First, I'm going to talk about the while loop. The while loop looks like this: while, expression, statement. Just like if statements, the expression in the while loop must be placed gently between 2 parentheses, neither here nor there. So we can use an example about school to illustrate how a while loop works. In plain English, it means that while you're under 18, you must attend school. Until the expression of your age is less than 18 returns false, the statement, you must attend school, is run. Here's a fancy little diagram reiterating what I just said. You start with your expression and evaluate it. If it returns true, the statement is ran. If it returns false, Java short circuits and skips the code inside the braces. With the previous example talking about school, with the code we have right now, we'll get something called infinite loop. An infinite loop is when a certain loop has no way to return false. The your age variable never changes. If your age is set equal to 16, the expression will always return true. But if I add this one little line of code, eventually the variable your age will be equal to 18, allowing the expression to return false. The loop boundary is a Boolean expression that evaluates as true or false. We must consider 2 aspects as we devise the loop boundary. It must eventually become false, which allows the loop to be exited, and it must relate to the task of the loop. When the task is done, the loop boundary must become false. I've already talked about attaining a certain count or limit in order to exit a loop, as with the school example. So, the second type of boundary construction involves the use of a sentinel value. In this category, the while loop continues until a specific value is entered as input. The loop watches out for the sentinel value, continuing to execute until the special value is inputted, and then breaking out from the loop. You've already used the break statement for switch statements, and here it has a similar use. Once the loop encounters the break statement, all further checks of the boundary condition are ignored, and the code execution continues until the end of the while loop. For example, here's a loop that keeps a running total of non-zero integers, terminated by the value of 0. Notice that because we don't know how many times we want to run the loop, we simply declare the boundary condition as always true. This means that the loop will run until we tell it to stop with the break command. This loop waits for the user to input a value, then checks that value. If it equals 0, then the loop is broken. If it is not 0, then the integer gets added to the total. Once the loop is broken, the total is printed out. Time for the for loop, which is one of my personal favorites. The for loop has the same effect as a while loop, but with a different format. The for loop is typically set up as follows. Statement 1 initializes the loop variable. Expression 2 is the Boolean expression. Statement 3 alters the key value, which is usually an increment or decrement statement. And finally, statement 4 is the code to be done during each iteration. Here is an example of a for loop used to print out integers 1 through 10. The loop starts off setting the counter equal to 1. It checks to see if the counter is less than or equal to 10. If the counter is less than or equal to 10, then the system prints out the number the counter equaled. Finally, 1 is added to the counter, and the for loop starts again, but without resetting the value of the counter. And here's a nifty diagram. A for loop is appropriate when the initialization value and the number of iterations is known in advance. The above example of printing 10 numbers is best solved with a for loop because the number of iterations of the loop is well defined. Constructing a for loop is easier than a while loop because the key structural parts of a for loop i.e. initialization, loop boundary, and an increment-decrement statement, are contained in one line. It is also easier to visually check for the correctness of a for loop because it's so compact. A while loop is more appropriate when the boundary condition is tied to some input or changing value inside the loop. So now for the last loop, do while. There are conditional looping situations where you want to have the loop execute at least once, and then evaluate an exit expression at the end of the loop. The difference between do while and while is where the expression is evaluated to exit the loop. If the expression's in the beginning, it's a while loop. If it's at the end, then it's a do while. The general form of a do while loop is this. And here's what a fancy diagram looks like explaining it. In contrast to the while loop version, the do while has the advantage of using only one input statement inside the loop. Because the Boolean condition is at the bottom, you must pass through the main body of a do while loop at least once. The same strategies used to develop while loops apply to do while loops. Make sure you think about the following 4 sections of the loop: initialization, loop boundary, the contents of the loop, and the state of the variables after the loop. And just like you learned if-else statements can be nested, so can loops. The following example will print a rectangular grid of stars with 4 rows and 8 columns. For each occurrence of the outer row loop, the inner col loop will print 8 stars, terminated by the new line character. Now go out there and code.